Chapter 9, Lecture 2, Subtopic 9.2, Discrete Random Variables. For the learning outcomes, at the end of the lesson, students should be able to find the probabilities from probability distribution table or function, cumulative distribution function, find the expectation and variance of discrete random variables. In general, we have the formula. Probability x equal to a, we can write down as probability x is less than or equal to a minus probability x is less than or equal to a minus 1. Or we can write down in the form of the cumulative distribution function fa minus fa minus 1. The example is probability x equal to 3 equals to f3 minus f2. Next, probability x is greater than a, we can write down as 1 minus probability x is less than or equal to a. It is equals to 1 minus fa. The example, probability x is greater than 4 equal to 1 minus f4. Probability x is less than or equal to b greater than a. It is equal to probability x is less than or equal to b minus probability x is less than or equal to a. You can write down using cumulative distribution function fb minus fa. The example, probability x is less than or equal to 7 greater than 5, we can write down as f7 minus f5. Next, probability x is less than b greater than a, we can written as probability x is less than or equal to b minus 1 minus probability x is less than or equal to a, fb minus 1 minus fa. The example, probability x is less than 6 greater than 4, it is equals to f5 minus f4. Okay. Then for the probability x is less than or equal to b greater or equal to a, it is equal to probability x is less than or equal to b minus probability x is less than or equal to a minus 1. That is fb minus fa minus 1. The example, probability x is less than or equal to 6 greater or equal to 2, we can write down as f6 minus f1. Let us look at the example 1. A fair die is rolled. If x represents the number on die, show that x is a discrete random variable. Find probability x is greater than 3 and b probability for x is less than or equal to 5 greater than 1. Okay, for the solution, the possible values of x are 1, 2, 3, 4, 5, and 6. We can represent the result in the table. For the x, small letter x is the possible value, that is 1, 2, 3, 4, 5, 6. Then the probability for each of them is 106, 106, 106. Okay, this is the result for the rolling a fair die. For the summation of the probability distribution function, it is always equal to 1. We can check. We can sum up all the probability, then we will get it is equal to 1. Therefore, x is a discrete random variable. We already shown. Okay. For the probability x is greater than 3, it is equals to probability x is equal to 4 plus with probability x equal to 5 plus with probability x is equal to 6. Then for each of them, their probability is 1 over 6. Plus them together, we simplify, we will get the answer is 1 over 2. Then for the probability x is less than or equal to 5 greater than 1, it is equal to probability x equal to 2 plus probability x equals to 3 plus with probability x equal to 4 and probability x equal to 5. Then each of them have the probability is 106, the value. After the summation and simplification, we will get the answer is 2/3. Example 2. The cumulative distribution function, that is capital letter F, of a discrete random variable x is shown as below. Shown in the table. Find the probability x equal to 3, probability x is greater than 2, probability x is less than or equal to 4, greater or equal to 2, and the median. Let's look at the solution. Probability x equal to 3, we use the formula when we are going to find out the probability x equal to a. We need to use the cumulative distribution function, that is fa minus 1, this one. So for our solution here, we will use f3 minus f2. By referring to the table that is given, f3 is 0.67, f2 is 0.32. We substitute into the solution there, then we will get the answer is 0.35. For the probability x is greater than 2, from the formula that we have learned, it is 1 minus fa when we are going to find the probability for x is greater than a. So for this one, we will get 1 minus probability x is less than or equal to 2, that is 1 minus f2. Then f2 is 0.32, 1 minus 0.32, we will get the answer is 0.68. Next, we are going to find the probability for x is less than or equal to 4, greater or equal to 2. By referring to this formula, okay, we will take fb minus fa minus 1. So for the solution, we will get f4 minus f1. f4 we have 0.90, then f1 is 0.20. After the calculation, you will get the answer is 0.7. For the median, we have the formula fm equals to 0.5. So 0.5, by referring to the cumulative distribution function that is given in the form of the table, 0.5 is here. So our median equals to 3, x equal to 3. Expectation of x for discrete random variables. Expectation, or the expected value of a random variable x, discrete or continuous random variable, is the mean of x and is denoted by mu or ex. Okay, this is mean. If x is a discrete random variable with probability distribution function px equal to x, then the formula is this one. Ex equals to summation x times with the probability. Expectation of any function of x. The definition of expectation, Ex equals to summation x times with the probability, can be extended to any function of random variables such as 3x, x squared, x minus 2 power to 3, and so on. If x is a discrete random variable with probability distribution function p, then the expectation of any function of x, gx, is given by egx equals to summation gx times with the probability. Important properties of expectation. Ea, where a is a constant, you will get a. Eax, where a is a constant, then we will get aex. Eax plus b, where a and b are constant, then we will get aex plus b. These are the properties of expectation. The above properties of expectation are true for both discrete and continuous random variables. Example 3. The probability distribution of a discrete random variable x is given as follows. In the form of table, this one is the probability distribution function. Okay, calculate Ex. For the solution, we use the formula Ex equals to summation x times with the probability. So our x is 1 times with the probability is 0.1. Our x is 2 times with the probability 0.3 plus with x is 3 times with the probability 0.3, then times plus with x equal to 4 times with the probability is 0.2 plus with x is 5 times with the probability 0.1. Then we total up the value, then we will get 2.9 as our mean, the expected value. Okay, now let us look at example 4. The probability distribution of a discrete random variable x is given in the table below. Still the probability distribution function. The question asks us to find the Ex, E2, E5x plus 2, Ex squared, E5x squared plus 2. If y equal to 3x plus 1, find the Ey. That's the solution. Okay, for E2, by referring to the properties that we have learned just now, where 2 is a constant, so our answer will become 2. Okay, if you want to do the calculation using the formula also can, the summation of the value 2 times with the probability. Finally, you will get the value of 2. For Ex, we use the formula summation x times with the probability. So for our x is 1, our probability is 1.6 for the first term, plus with x equal to 2 times with the probability is 2/6. Then when x equals to 3 times with the probability 3/6. For the summation, we will get 7/3 as our answer for the Ex. That is also represent our mean. Okay, next for E5x plus 2, we can use the formula, that is summation 5x plus 2 times with the probability. 5x plus 2 when our x equal to 1 times with the probability, that is 1/6 for the first term. 5x plus 2 when our x equal to 2, our probability is 2/6. Then 5x plus 2 when our x equals to 3, our probability is 3/6. Then our final answer will become 41/3. 41/3. Alternatively, by using the property of expectation, we also can solve the part C as expected 5x plus 2 equals to 5Ex plus 2, where we get our Ex from the part B, 5 times with 7/3 plus 2. Then finally we will get the answer 41/3, same like the calculation using the formula. Next, to get the Ex squared, we use the formula summation for the x squared times with the probability. So when our x equal to 1, we need to square it. Then times with the probability, that is 1/6. When x equals to 2, we square the x. then times with the probability 2 over 6. When x equals to 3, you will get 3 square times with the probability is 3 over 6. Then finally we will get our answer is 6. For the 5x squared plus 2, we use the properties of the expected value. We will get 5ex squared plus 2. Ex squared we get from the part D, that is value 6 here. Then we will get our answer is 32. For f, ey equals to e3x plus 1. So we use the properties of the expected value. We will get 3ex plus e1, where the e1 is 1. Then expected value we get from the part B, 7 over 3 times with the value 3. Finally, we will get ey equals to 8. Variance of discrete random variable. Variance of a discrete random variable x is denoted by VAR x, or sigma square, and is defined as variance x equal to ex square minus ex all square. This is the formula that we need to memorize. Okay, next, for the standard deviation of x, it is equal to square root of the variance x. The variance of x is always positive. Important properties of variance for the discrete and the continuous random variable. The first one, variance a equal to 0, where a is a constant. Variance ax equals to a square variance x, where a is a constant. Variance ax plus b equals to a square variance x, where a and b are constant. This is the properties of variance. Example 5. The probability distribution of a discrete random variable x is given as follows. Calculate ex squared, and variance x. Okay, so for the solution, for ex, we use the formula summation of the x times with the probability. Summation of the x times with the probability. So our x equal to 1, our probability is 2 over 7 for the first term. When x equals to 2, probability is 4 over 7 for the second term. And when x equals to 3, times with the probability that is 1 over 7, then our summation will give us the value is 13 over 7. Okay, for part B, we are going to find out the ex squared. So the formula is summation x squared times with the probability. Okay, we take the x, then we square it. 1 square times with the probability, 2 square times with the probability, 3 square times with the probability 1 over 7. Then our calculation will give us the answer as 27 over 7. Okay, for part C, to find the variance of x, we have the formula variance of x equals to ex squared minus ex all square, where our ex squared we get from the part B, 27 over 7, minus ex we get from part A, then we square it. The answer for the variance is 20 over 49. Now let us look at example 6. The probability distribution of a discrete random variable x is given as follows. We are going to find out the variance x, the variance 2x plus 3, variance x minus 2, variance 5 minus 8x. Okay, for the first one, to get the variance x, we need to find out the ex first using the formula of the expected value, this one. Then we will get ex equal to 41 over 16. Second step, we need to find out the ex squared. So we need to take the x, we square it, then we times with the probability. The calculation will give us ex squared equal to 117 over 16. That we will apply the formula of the variance. The formula of the variance is ex squared minus exr squared. Then we substitute our ex as 41 over 16. Our ex squared is 117 over 16 into the formula of the variance. Then after the calculation, we will get the variance is 191 over 256. For the variance x minus 2, we can use the properties of the variance. So we will get variance x minus 2 is equal to variance x. This one we use the properties of the variance. Then the answer is 191 over 256. Okay, next is to find the variance of 2x plus 3. Using the properties of the variance, we will get it is equal to 2 square variance x. So 2 square equals to 4 times with the variance x is 191 over 256. The answer is 191 over 64. Next is the variance 5 minus 8x. We also using the properties of the variance. We will get negative 8 square times with the variance x. It is 64 times with 191 over 256. The answer is 191 over 4. So that's all for lecture 2. Thank you.